When we first started learning calculus, I've always asked you to accept that when you differentiate something like this here, the n goes down like this. That's this n here, and then this here gets minus by 1. I've always asked you to take my word for it that this is always true. And at one point we used a binomial expansion here to prove that when n here is a positive whole number here, this will always be true. So this statement, but by using the binomial expansion, we've already proved that this statement here is true. But don't forget, this statement is only true when you have n, where n is a positive whole number. So it's only true when it's this, or x to the power 4, or x to the power 5. It's only true when n here is a whole positive number. Well, we don't know if you can do this. I've always asked you to accept that. Even if it's a negative, you can still take it down. But you don't fully understand why, or why it's true, even when it's a negative. So in this video, we're going to try and understand why it's true, even if it's a negative. Because the binomial expansion here only explains that it's true if n here is a positive whole number like these ones here. Okay, so in this video we're going to try and understand what happens if it's a minus, like x to the power of minus 4. Why this here is true. Why when you differentiate this it will give you minus 4x to the power of minus 5. Okay, but before we start, you see the binomial expansion proves that when these are whole positive whole numbers, then it's true. If you take the case of when n equals 1, it's also true, because x to the power of 0 here, when n equals 1, this is what you will get. When n equals 0, here, then x to the power of 0 is 1. Okay, x to the power. So when you differentiate 1, it will give you 0. So when n equals 0, you're going to have 0 here times whatever. 0 times whatever is going to be 0. So you see this statement here is true even if n equals 0 here. So the binomial expansion proves that when n equals a positive whole number, then this statement here is true. But then now accepts that when n equals 0, this statement is also true. So far this statement here is true even if n equals 0. So even if n equals 0, it will still be true, because if you put it into here, then this thing here, when you differentiate 1, you will get 0. Because even if you put 0 into here, then 0 times whatever, it will still be 0. So this statement here is also true when n equals 0. Okay, so far it's true when n equals 0, 1, 2, 3, 4, and so on here. Okay, so so in the next video we're going to try and understand why it's true when it's negative as well. Okay.